an atmospheric scientist, okay, a political scientist, and a philosopher walk into a bar. It's actually not a joke. That's actually our lineup for tonight. So, all right, no, I'm very excited about this lineup because we have some great thinkers on the topic of geoengineering. Of course, the topic for tonight's presentations, climate engineering, what is it and should it be field tested? Our three panelists tonight, or actually our four panelists tonight, Stephen Gardner, Thomas Ackerman, Sakina Jinnah, and Christopher Preston. I am going to just introduce Steve real quickly, and then I'm going to turn it over to him to tell you a little bit more about his program and the project that he's part of right now. So let me introduce you to Steve Gardner. He's a professor of philosophy and a Ben Rabinowitz Endowed Professor of the Human Dimensions and the Environment at the University of Washington in Seattle. Oh, that's right, University of Washington in Seattle, where he also directs the programs on values in society. His research focuses on global environmental problems, future generations, and virtue ethics. He has a casual interest in breweries. So actually, this is a great location for him. He once wrote an essay about all the pubs his grandfather took him to on vacation. His mother discovered this essay when it was posted on the wall at an open house that she attended. And this was back when he was in kindergarten. So this lifelong love affair with pubs and breweries is now continuing here tonight. So let me turn it over to Steve. Let's give a warm welcome to Steve Gardner.
Well, it's a great pleasure to be here. Here I get to hold forth in a pub. Grandpa, I salute you. I'm sure you're feeling very proud. I'm here just to say that we have a group of people at the University of Washington who have been interested over a number of years in this whole question of whether we should, whether people in general, whether the planet should engage in engineering the climate, by which we mean grand technological interventions, especially to combat climate change. And right now there's a conference going on focused on questions of justice and political legitimacy that come up when you think about geoengineering. One thing I want you to realize right from the very beginning is that the people at the UW, and we have many visitors here from elsewhere today, have very diverse views on this subject, right? There is not one UW view. There's not a camp. And it's important to realize there's great diversity and people at different ends of the spectrum about what we should do and why we should do it. Personally, I have been called names about my attitudes about geoengineering, but interestingly, I've been called sort of names across the spectrum. Right, I've been accused of being a member of the geo clique, right, that wants to promote geoengineering. I've also been accused of being a geoengineering obstructionist, right, of being very anti-geoengineering and having the same kinds of views as the guy who popularized the term geo clique. So even how to interpret me turns out to be a funny kind of question. I think the thing that I've emphasized most in talking about geoengineering is the way we should understand geoengineering in the wider context of what's going on with climate change, and in particular, in my view, the collective failure to act in a reasonable and ethically defensible manner on climate change. I think there are interesting reasons why climate change is called such a failure, and among those reasons are it's a really pronounced ethical challenge that makes it very tempting for the current generation, particularly in the more affluent countries, to engage in bad behavior, if you like, imposing costs on the global poor and especially future generations and the rest of nature. And I have a big book called The Perfect Moral Storm on this that some people might be aware of. When it comes to the way we talk and think about geoengineering itself, some of the key worries I have there are about that it's easy for us to become corrupted in the way we talk about geoengineering, right? In particular, by being too positive, which is why I get my reputation for being an obstructionist, I guess, right? Often when we're talking about geoengineering, we're talking about what some people call technological imaginaries. So things that we don't yet know how to do or don't yet know how to do at the scale that would be necessary. And yet we talk about them as if we really did know how to do them. And that's a real serious issue. But I also think we often talk about ethical imaginaries as well, right? We talk about what would justify geoengineering in a world that was perfectly just and wonderfully well governed. But of course, that's not the world that we inhabit. And it's a very different question to ask, what would geoengineering look like and how could it possibly be justified in the world that we actually inhabit? That's all big, serious stuff, though. So now I'm going to get a little more lighthearted and introduce the panel members. First person I want to introduce is Professor Tom Ackerman from Atmospheric Sciences. He's looking worried already because he teaches with me a course on this topic. And it's fair to say he and I have an interesting, fun relationship. Here's what he says about himself. He's Professor of Atmospheric Sciences and Director of the Joint Institute of the Study of the Atmosphere and Ocean at the University of Washington. His main research interests are in the energetics of the climate system. And then I get bored, you know, blah, 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 climate models, satellites, and so on. But he's also interested in the intersection of science, religion, and ethics, and he's published articles in these areas as well as the illustrious scientific areas. Oh, and he mentions that he has taught with me. And, you know, sometimes he doesn't overrun, and I actually get a chance to say something in those classes. Welcome, Tom. Hey. So the second person I'd like to introduce is Sakina Jinnah. I didn't check with her that that was the right way to pronounce that. It's close enough. Okay, thank you. Fortunately for Sakina, I don't know her very well, so I don't have any nasty stories to tell about her. She holds a PhD from the UC Berkeley, and her first book, Post-Treaty Politics, Secretariat Influencing Global Environmental Governance, won a very prestigious award from the International Studies Association. She's currently interested in global climate change, and again, blah, 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 huge honors, you know, blah, blah, blah. More interestingly, she has 3 little boys, 2 of whom are identical twins, to which she says, no, it's not genetic. Yes, it's hard. No, she wasn't planning on 3 anyways, blah, blah, blah. And she's also an Ashtangi and general lover of the outdoors. So welcome to Sakina. And then our final panelist is Christopher Preston, who's professor in the Department of Philosophy and a research fellow at the Mansfield Center's Program on Ethics and Public Affairs at the University of Montana. He works in environmental philosophy, climate ethics, the ethics of emerging technologies, and feminist philosophy. I think it's fair to say that Christopher is one of the founding people on the ethics of geoengineering, and many of us owe him a great debt for some of that foundational work. He also says he's a keen mountain biker, a cross-country skier, and vegetable gardener. And then, as if to balance things out with less savory things, he says he's a native Englishman who is now residing in the arid Mountain West, and he comes to Seattle as often as he can in order to get rained on. Yeah, and I'm struggling to think of anything mean to say about Christopher because he's such a lovely guy. I'll try and think of something while they're talking. Thank you very much.
Thank you very much, Steve. Well, after that great introduction, I think we should just go ahead and get started. So who's here to listen to some climate scientists? You guys? All right. That sounds pretty good. All right. So our first presenter is Tom Ackerman from UW Atmospheric Sciences. Tom, you want to come on up?
Well, Steve should know that it's not good to insult the person who's coming up after you. Now, Steve and I do have an interesting relationship, and no, I don't always overrun when I teach with Steve, and he teaches philosophy, and boy, is that hard to follow. All right, so for the simple stuff, why are we even thinking about solar climate engineering? This is a little bit of a complicated slide, but I want you to notice that this is time down here, and this is temperature, this is where we've been, and this is where we project to go in the future. And this is the Paris Accord, about 2 degrees, 1.5 degrees of warming. In order to get there, you have to follow these 2 blue curves. How do you follow those 2 blue curves? Well, there's a heavy reliance in those scenarios on switching to renewable resources and a very heavy reliance on something called negative emissions. That is, removing carbon dioxide from the atmosphere. Unfortunately, we don't actually know how to do that. We don't know how to remove carbon dioxide from the atmosphere. The guys who I took this from in this article says their guess is that barring unforeseen and transformative technological advancement, so in our words, a miracle, in the next 10 years, anthropogenic emissions need to peak within the next 10 years to maintain realistic pathways in order to be on one of these curves to get to 2 degrees. All right, we're not going to have that miracle, I'm pretty sure, in the next decade. So what do? Well, we think about if you can't get reducing carbon emissions, one way to keep the Earth cool is to think about solar climate engineering. Okay, one way to frame this whole field is here's the climate system, here's the human actions that cause climate change. I disagree with one of the answers to the questions. We actually started geoengineering this planet 1,000 years ago when people started cutting down trees and burning them down so they had clear spaces to plant their crops. Now we're just doing it in a lot bigger way. There's the climate system, here's the climate impacts that come from human actions. So we talk about mitigation, which is the way in which we might not produce so much carbon dioxide. If we don't do mitigation, we've always said, well, we're going to have to do adaptation, because if you don't fix the beginning, the only thing you're going to get is the end. But now there's an intermediate thing, which is geoengineering, which is saying, is there a way to manage the climate system in a way that doesn't allow these bad impacts to occur? I mentioned there's 2 kinds. This is carbon dioxide removal. The carbon dioxide removal looks a little bit like this. What we're doing right now is we burn fossil fuel and we get CO2. We can think about trying to capture that CO2 so that when we have fossil fuel burning, we catch some of the CO2 and we store it somewhere underground or somewhere else. That doesn't get rid of all the CO2. We can think about biomass energy, which is the idea that we would grow plants. We would burn those plants for fuel, and we would catch the CO2 and we would store that somewhere. And finally, there's this system, which is basically summing up both of these, and this is what gets called negative emissions. This is the idea that we're actually removing CO2 from the atmosphere and reducing the amount of CO2 that's in the atmosphere. We are uncertain how to scale these processes. We sort of know how they work on a small level. Christopher and I both know how to raise our vegetables. We could, in principle, burn the vegetable crop and produce the CO2. Some of these processes are not well understood. It takes we think it's a long time scale to get to this BECCS, the biomass energy with carbon capture and storage, about 50 years. And almost everyone views this as a positive step if we knew how to do this. Okay, what I do want to talk more about tonight is solar climate engineering. There's been a number of ways proposed to do solar climate engineering: mirrors in space, clouds, adding particles to clouds, and reflective aerosols. And yes, I do joke about moving the Earth away from the sun, but I don't know how to do that. Okay, so the idea behind particles in space is very simple. This is a picture of the eruption of Mount Pinatubo, which happened in 1991. This is a picture taken about a month later from the space shuttle. And you can see these layers that are now in the atmosphere. Those are layers of particles that came from the volcano. That volcanic eruption in the short term reduced the temperature of the planet by about 2 degrees. It recovered again after the aerosol went away. So the concept is you could use a series of high altitude planes to put stuff into the stratosphere, which would make a stratospheric aerosol layer. These particles would spread around the globe in sort of a month, maybe spread through the hemisphere in 6 months. A lifetime's about 4 years, so you have to keep doing it every couple of years to replace this, and you would cool the planet. Marine cloud brightening, which is the other technique. This is a picture of the west coast of the United States. This is a low cloud layer, and you can see these streaks. These are ship tracks. Underneath every one of those bright streaks is a large ship, container ship, tanker, sailing along, emitting things out of its smokestack. That stuff's going into the cloud, and it's modifying the cloud and making it brighter. So we have this concept that we know works of putting stuff into the clouds. Every cloud drop needs a nucleus. So if we add more nuclei to the cloud, we have the same amount of water, we'll get more drops and they'll be smaller, and that makes them more reflective. So that's what's going on in every one of these ship tracks. So the concept is that we can do this in marine cloud. When you put up stratospheric aerosol, you're basically going to end up with a situation where you're going to cool the hemisphere and the globe because the particles spread all over the hemisphere. When we do this marine cloud brightening, we can do it locally because the aerosol that we put in the marine boundary layer, these little particles, only last for a few days. So you have to keep replenishing them, but you can keep it to a local effect. So we can imagine doing it locally, or we can also imagine it doing globally by doing this in a lot of different places and summing it up. Would require a fleet of ships. This is a rather futuristic vision of robotic ships that are run by wind power, and they're busy spraying salt water into the atmosphere, making little tiny salt particles, which then go into the clouds and become nuclei for the cloud droplets. Particles dissipate, so you have to do this frequently. Okay. Whoa, cut that out.
All right.
What are you doing? You okay?
Keep talking.
Okay. All right. So most of the time, when we talk about solar climate engineering, people immediately want to leap to deployment. What I want to point out is we aren't actually at deployment. We're way back here trying to figure out if things actually work. And there's a long arc that we go through from the process, and these are testing to see how it affects the climate system and ultimately deployment. And you can think about a timeline for this, and this is an incredibly optimistic timeline, and it says it might take you 20 years. And one of the reasons I say this is incredibly optimistic is that this assumes that we're going to get timely and adequate funding. And I've been in this business a long time, and I've never had timely and adequate funding, so I should know right now that's not going to happen. Okay, so right now there are 2 experiments being proposed to do solar climate engineering to test these processes. And remember, we're not talking about deployment. We're talking about testing the processes that might work for climate engineering. One of them is a cloud brightening experiment, and my colleague Rob Wood is sitting here, and Rob Wood and I are the co-investigators on that project. And then there's a project out of Harvard which is proposing to use balloon in stratosphere, and I've got a picture of that. This is an experiment that's currently being developed and is planned to be run within the next 6 months. And the idea would be they would fly a balloon into the stratosphere, so this is about 12 miles, 14 miles up, and they would lay down a water, like a contrail from a plane, a bunch of water droplets, which would turn into ice. They would then lift up their little device, swing the balloon around, and come back and sample what's happened so they can look at how these water droplets, ice crystals, will evolve in the stratosphere. This looks pretty simple, but I know from past experience of my own that actually leaving something in the atmosphere and coming back around to sample it's a real trick. And they're going to have a balloon that they're steering from the ground trying to make this work. So it's a challenge. we are in the process of developing our own experiment. This is a nozzle that works in the laboratory, sprays about 1 trillion particles per second of little tiny salt crystals. What we need about a couple 100 trillion per second. So our design is that we would take a bunch of these, put them in one of these snow cannons, big fan behind it. It wouldn't look like this because we wouldn't be blowing snow. We'd be blowing lots of little tiny water droplets into the atmosphere. We would do this on somewhere down in the coast of California, and then ultimately out in the ocean with a ship. So we'd have a sprayer ship and then use airplanes to sample what happens in the clouds. Both of these experiments are very small scale, no climate impact, but they're a start to understanding the physics. So suppose we were going to have a full-blown research program on solar climate engineering. What would it look like? Well, this is a schematic. There's need to do a bunch of computer simulations, field campaigns I was just talking about for stratospheric aerosols, marine cloud brightening, detection, how do we know what we're doing, and then an ethics and governance piece that involves the sort of discussions we were having today. And I put this up to kind of indicate where we're actually working on things on this diagram. None of us, I think, would say that we're anywhere near complete on any of these boxes, but there are people doing global climate modeling. There are people modeling the local process, like how do these aerosol particles interact with the cloud particles. We have the 2 experiments I just suggested to you. There's a whole bunch of people working on ethics that could all raise their hand. And also there are policy people doing rules and regulation kinds of discussions. Okay, so where are we in terms of the science? We understand the science, and we have basic analogs for this science. But there's a great deal that we don't know about the specific details. There's a lot of things which we need to know about how to control the technology. It's not enough to say I can make, in our case, it's not enough to say that we can make a ship track. We want to know how much aerosol we have to put in order to make that ship track and how that ship track is going to affect the reflectivity of the cloud. This is the engineering side of the problem. So there's a lot of stuff we don't know. We have models that have been used to do sort of first order evaluation of whether or not these kinds of techniques work. But we need a lot more of the modeling, and we need experimental results to test whether those models are in fact correct. The process experiments that we're talking about, this sort of stepwise progression to understanding whether we can do this, is probably going to take us a decade to complete. We need a research program, but there is no federal funding for this anywhere in the United States. There's not actually funding for it anywhere in the world from a recognized national government that I know of. There may be a couple that are doing it that I don't know about. Okay. That's it. Thanks.
Thank you very much, Tom. All right. Well, that was excellent. You know, there's nothing like learning about geoengineering to make a person thirsty. And if you're as thirsty as I am, you might want to ask the server to grab you another beer. Well, that was great to give us an overview of the science of geoengineering and some of the technical aspects. Now we're going to move on and talk about some of the policy implications and policy aspects governing geoengineering and geoengineering research from our next presenter, Sakina Jinnah from UC Santa Cruz. I almost said UC Davis. That'd be terrible. Yeah, a banana slug. All right, let's give it up for her. Thank you.
Thank you. Oh, great. Oh, I'll just stand here if that's okay. All right. Can you hear me through the mic? Yeah. Okay. So I'm going to talk a little bit about the political context in which Tom is trying to do his research. And most of my work focuses at the international level. So I'll focus in particular on some work I'm doing on how international institutions might get involved in this space in terms of governance. So for those of you who are at my talk this afternoon, it'll be something new and different. Okay. So the first thing I wanted to mention is, again, to kind of reiterate some of what Tom said, but also just tell it through my lens about why are we talking about this now. It was true for quite a long time that any discussion of climate engineering was considered taboo. And as one of my colleagues, David Victor at UC San Diego, said once in, I think, 2009, climate engineering is a freak show in otherwise serious conversations about climate science and policy. And in 2009, that was true. But things have shifted quite a bit in the last couple of years. Things have softened, the discourse has softened, and you're starting to hear conversations about this topic come up in all kinds of different places. And so some of the reason for that is the Paris Agreement, which was agreed at the end of 2015. And some of the language in the Paris Agreement on climate change, this is the UN Agreement on Climate Change, that was negotiated and kind of loosely speaking to replace or be the successor to the Kyoto Protocol, did a few things. There are three things that are pretty important in there. So first, as Tom mentioned, it talks about net zero emissions. And he explained it, but just one more time, this is the idea that we can take out of the atmosphere more carbon than we're putting out into it. Right? So the Paris Agreement calls for net zero emissions by the second half of this century. And that, as Tom said, necessarily, in many people's eyes, means carbon dioxide removal strategies. It necessarily is a call for climate engineering. Secondly, the Paris Agreement set some temperature targets, right? And this was a big deal politically. It was the first time we had this in a global agreement. So what parties agreed to, what the countries that are party to the agreement agreed to do, is to limit the amount of warming we're willing to accept, right? So they set that cap at 2 degrees above pre-industrial levels, and they said we'll aim to keep it below 1.5 degrees. Now, how do they go about meeting those targets? So the way they go about meeting those targets are through what we call nationally determined contributions. And essentially what that means is that countries just decide, they pledge what they're willing to do domestically to work towards that goal, irrespective of what the overall target is, okay? And so I've just cherry-picked from the UNFCCC's website, the UN Framework Convention on Climate Change's website, several of the NDCs, the nationally determined contributions, of some of the most important players in this space. And I put the United States in parentheses because, as you probably know, the US is in the process of withdrawing from the Paris Agreement. But nonetheless, our pledge is important for a variety of other reasons. And so the point I want to make with this is that when you look at what different countries are pledging to do, it's a hodgepodge. They're not easily comparable targets. So you have everything from what we would call an absolute economy-wide emission reduction in the case of the bottom three, to things that look really different, things that look like peaking emissions or switching over the share of our economy to renewables. The share of our energy capacity to renewables. So there's an NGO called Climate Action Tracker, and I pulled this slide from their website. And they did a really nice job of aggregating all of these really difficult to compare pledges and projected out to 2100, what does this all mean vis-a-vis our target under the Paris Agreement? And what they find is that if, and this is a big if, let me point to where I'm looking at the red band. What they find is that if all the countries that pledged these NDCs, if, actually meet those obligations, right? If they actually fully implement those pledges, then we're looking at, in a best case scenario, a 2.5 degree, missing the 2 degree target by at least half a degree. Okay, and that's actually a big deal. That's a lot. So this is another rationale that we're hearing, and one more reason why we're starting to hear about climate engineering as a way to fill what we call, in the political jargon, the ambition gap, right? The gap between what countries say their target is, i.e. keeping us below 2, and what their pledges actually get us to, which is maybe in best case, by this estimate, 2.5. Okay, so there's an ambition gap, and climate engineering is increasingly being talked about in the context of how do we fill that gap. And this is a reproduction of some of what Tom already said, but the point I wanted to make here is that another place where we're seeing this conversation come up is in the Intergovernmental Panel on Climate Change scenarios. So the only thing I want you to take from this is each one of those colorful lines is a scenario that projects out into the future what our temperature response would be on the basis of a variety of different factors, including the political decisions we make. And what these models show us, and there are how many? Over 1,000 in this. There are, to get us to 2 degrees, at least more than 50% of these scenarios incorporate carbon dioxide removal, BECCS, and all of them that get us to 1.5 incorporate it. So this is another signal, or another symptom and signal of why we're seeing more conversation about this topic right now. So finally, just a quick mention about cost. And A lot of times we hear about climate engineering as framed in a way, or at least SRM technologies in a way, that are cheap and fast. And I think this is a really problematic framing, but it's certainly one that's out there, right? I mean, most of the cost estimates that I've seen, and maybe there's an economist in the room who knows better, but they only account for direct costs, right? We're only thinking about costs now, and we're not thinking about, or we're not incorporating externalized costs. So for example, costs related to ecosystem degradation, costs related to avoided healthcare costs, related to sort of coal burning, et cetera. So why do we want to govern it, right? What are the governance demands? And I should be clear that when I'm talking about governance, I'm not talking about regulation per se. That could be a piece of governance, but governance includes a wide swath of types of tools and strategies that we could use to shape the way this technology fits into our collective future or not. So I've listed here some of the types of risks and uncertainties that we need to be thinking about and that demand governance. And I know that Christopher will talk about the moral and ethical issues, so I'm not going to go into that right now, but just to note a couple of the political issues. So there are several people who talk about the risks associated with SRM, in particular solar radiation management, as having security concerns, right? And so these are concerns related to, I mean, I've seen SRM being categorized as a potential weapon of war, right? And that we could use it to control weather in other countries and use it for military purposes. There's also, of course, on the other side, food security related issues, which we hear about more in the context of carbon dioxide removal strategies and thinking about how much land it would take to scale up some of these technologies to have a meaningful impact on climate change, whether or not that's even possible. And then, of course, there's this question of power and control. And this image on the right is one that was critiqued today by one of our colleagues, but nevertheless one that is pretty common to see as you navigate this space, which is to say, if we can deploy this stuff to address climate change, who gets to decide how much, by when, and who gets to deploy it? Who gets to control the global thermostat is the frame. So these are just a handful of the political questions. And of course, some of my work is also talking about, well, what's the role of the public in all of this? So how do we engage in how do we engage the public to help make some of these decisions about what role this technology may or may not play in our future? Another reason we want to govern it, and I think we want to govern it now, is because we do have proposed experiments coming down the pike. And in contrast to some of my conversations with Tom this afternoon, I'm not out to get you. I'm not saying that we need to stop your experiment, but I actually think your experiment provides a fantastic opportunity because, well, I'll get to that in a second, because it's relatively, okay, the controversy is relatively low surrounding it. It presents a great opportunity to start engaging the public in thinking about some of these issues and learning about what you're doing and thinking about what are the value judgments and what are the ethical concerns and political concerns that might be of interest. So don't get bogged down in that side of the slide. This is the kind of important piece on the left. And this is a colleague of ours attempt to map what does the SRM governance space look like, SRM research space look like. And he says it moves down, we can categorize different pieces of research as either having no environmental impact in the green bubble at the top, having negligible environmental impacts in the orange bubble, and having increasing transboundary environmental impacts in the red. And I think it's fair to say that most scientists agree that Tom's experiment falls right here, right, in the orange, that we don't expect to have any environmental impacts as a result of what he's doing. But what we also don't have is anything to prevent us from blindly, as Katrina framed it this afternoon, sleepwalking into the red bubble, right? So we don't have governance mechanisms. We haven't had conversations to think about under what conditions might we be willing to move into the red bubble? Under what conditions should we not do that at any cost? So quickly, I'll say just a little bit about some of what I've been working on. And this is from a paper that's coming out in January in Climate Policy. If anyone doesn't have access to academic journals to the university, I'd be happy if you email me to email you a copy of that. That's the top one. I talked about the second one this morning. And what we talk about in this paper is we propose a framework for thinking about how governance should unfold at the global level. And I'm going to kind of skip through a couple slides because I know I'm short on time. But what I would really like to talk about is what that architecture looks like and different ways we could envision what a global architecture for this issue looks like. So there's 3 different roughly proposals for how we can design governance structures internationally. The first would be a single lead institution. So this would be something similar to like the World Trade Organization in the late 1990s, right? It's increasingly less common, but at that time the WTO was the only game in town in international trade politics. We don't really see that so much anymore in most areas of governance. So it's really much more difficult to do and very difficult to conceive. It's also highly unlikely because nobody wants to take this on. There isn't an international organization that wants to take on this issue. The UNFCCC, the United Nations Framework Convention on Climate Change, wouldn't touch this with a 10-foot pole right now, which would be sort of the natural place people jump to. So, maybe the climate convention should take it on. The politics underlying this are just, they're not amenable to being taken on by a single institution right now politically. That's the political reality. So the second model we might think about is what we call a club model. And this is the idea that you have a handful of countries, maybe it's the 10 or 12 countries that could conceivably actually deploy solar radiation management technologies in a reasonable time frame, who get around a table and start talking about how they want to see governance unfold. So this is something like you might see in economic policy. So G7 is an example of this. NATO is an example of this. You see it in security politics. We argue in our paper, and I would assert that the sacrifice you make for participation in this kind of model is too great to consider this model, that there are too many voices that need to be heard in this discussion, and that alienating or marginalizing countries that don't have technological capacity from being part of this discussion is just not is not only not ideal, but I would say inexcusable for this type of issue. So what we settle on in this paper is an idea that's called polycentric governance. And this is one that is complicated and messy, and it's sort of, it's about having multiple spheres of governance that run in parallel to one another and in tandem to one another. So you have governance at the local level all the way up to the international level and across sectors as well. So everything from private sector governance mechanisms to civil society to the traditional way we think about governance in the public sphere. So just to give you a sense of what I'm talking about, what we argue for in the paper as well, I mean, one of the problems with this in terms of thinking about what would happen just at this international public sphere area, right? We talk about the lower half in a different paper, is getting organizations on board. And as I mentioned, I don't think there's an organization out there that would be willing to take full responsibility for this. But that said, there are several organizations, international organizations, that have relevant capacities and demonstrated interest to take on specific slices of this puzzle. So just for example, and this is not inclusive of everything we discuss in the paper, but for some of the very specific proposals that we lay out in the paper. So for example, we think that this should be considered in the global stocktake under the Paris Agreement. There's organizations that have actually relevant capacity to figure out how that could be done. There's organizations that have relevant capacity to develop a transparency mechanism that may not take on other aspects of this problem. Now, I want to just underscore one thing, that I'm talking about near-term governance, right? So these are not heavily prescriptive proposals that are talking about how this should be governed in the longer term. And I'm very sympathetic to the view that Katrina mentioned earlier today, that we need to think really creatively about new governance mechanisms to help take on this task. But that said, I think in the 0 to 5 year term, we need to start thinking about what do we have right now that can help us to start chipping away at some of this puzzle. So I'm out of time, so I'll stop there. But thank you so much for your attention.
Thank you very much, Sakina. Well, that's great. So we're starting to see that there's issues with geoengineering and moving forward with this research really requires an interdisciplinary approach. And so I'm very excited for our next presenter, who's going to take us one step further with this interdisciplinary approach. Our next presenter is Christopher Preston, from the University of Montana, and he's going to be talking about the ethical considerations for geoengineering and geoengineering research. So with that, let's give it up for Christopher Preston.
All right. I want to start by just underscoring something that both Tom and Sakina said. Field trials, legitimate legal field trials, are starting in 2018. So it's important to talk about this stuff now. Tonight's a good time to start. We're actually sort of shifting into a different phase of the process here. And so before I talk about the ethics of field trials, I want to start with a little bit of a parable, if you like, a sort of big picture parable, which I think brings the ethics into focus a little bit. So this is a nice place. We all live here. And for about 10, 12,000 years since the end of the last ice age, it's been the home to everything that we do, everything that we know. It's where the world's religions were born, this time period. It's where written language started, where agriculture started. This is the familiar Holocene epoch in which we have enjoyed our lives so far. There's a little bit of disagreement over there, but an English philosopher called John Stuart Mill called this Holocene epoch, or called this period, the cradle of our thoughts and aspirations. Okay, so there was this place out there, and then something happened. What happened is we raised the temperature. And this is the famous Keeling curve, and the measurements started about 1958, and they start at 315 parts per million of carbon dioxide. And they continue today to somewhere around 405. And we changed the planet. We changed it inadvertently. This was an accident. We didn't say, let's industrialize and let's warm up the planet. But we changed the planet. And Bill McKibben, some of you might have read some of his work. He wrote this book, The End of Nature, in 1989 about climate change. And if you read the remarks he made here, he was literally saying, we're in a different place now. The world has changed. Meanings have changed. There's something philosophically significant going on here. And so McKibben coined the idea of Earth 2. So this is this warmer planet, slightly unfamiliar, the one we're kind of entering at the moment. He called it Earth 2. The geological scientists have been calling it the Anthropocene. This is not yet official. Technically speaking, we're still in the Holocene. Okay, but this is the sort of general consensus is that we've entered into the Anthropocene. Now, if we climate engineer, we start to make changes on a global scale that are deliberate, okay? And it's the fact that they're deliberate which makes me disagree with what Tom said earlier, that we've been geoengineering for thousands of years. It's the fact that in future we might deliberately alter global conditions, and in particular in this case with solar radiation management, we're going to deliberately alter the amount of energy that comes in through the atmosphere. The fact that we're going to do it deliberately means that McKibben's Earth 2 becomes something else, Earth 3, you might call it. And this image sort of represents satellites and space junk around the Earth. A better image really would be an Earth where we're actually changing the metabolism a little bit. Some of the sort of fundamental parameters, the amount of solar energy that strikes the surface of the Earth and the oceans. This, as I see it, counts as Earth 3. And perhaps it even deserves a different name, not even the Anthropocene anymore, but something like the synthetic age. So to get back to what I said at the beginning, we're entering, or we're pushing towards something fairly different. And the beginning of these field tests, I think, is an interesting marker as to whether we're going to go down this sort of different path. And so it really is, I think, a different path. And so it's a path that ethicists have sort of started to become pretty interested in talking about. Now, to get to the field tests specifically, I think you can say there's sort of a set of steps you kind of go through. From first thinking, having the idea about climate engineering, and incidentally in 1965, Lyndon Johnson's science advisors submitted a report that mentioned the possibility of engineering the climate back in 1965. It was, most people agree it was around 2006 that Paul Crutzen, a Dutch atmospheric scientist who'd won the Nobel Prize for his work on our destruction of the ozone layer, he legitimized actually talking about it. And then there's been a lot of in-lab tests to date. And then, as I was saying, we're currently sort of somewhere around here, getting ready to move from the lab into the field, and then sometime beyond that, maybe or maybe not deploying. Now, that image makes it look like there's a very orderly progression down this line, and you can imagine some very serious ethicists and very serious political scientists discussing things at every step of the way. But of course, it's not going to be an orderly progression down that line, because all sorts of random and bizarre things can change the way that line progresses. I mean, what could happen? The Greenland ice sheet could collapse. A rich, developed country could elect somebody who doesn't believe in climate change. Strange accelerator events could happen that sort of push the discussion off in certain directions. And things that we can't even imagine right now could happen that would all turn this straight line into something much less predictable, much less wavy, much less straight, much more wavy. And so I think the question as we face now with regards to possible field tests is, what will field tests do to this line? Will they sort of accelerate it? Will they push it out in one direction? How will field tests influence this pathway, this trajectory? So, as you've heard tonight, there are highly reputable people considering embarking on field tests coming up in next year and in years beyond that. And there's plenty of good ethical reasons to proceed with these field tests. And so knowledge for knowledge's sake is almost always a good thing, right? We can sort of, it's hard to find a problem with the idea that it's good to know more rather than less. David Keith, who will be involved in that field test that the Harvard group is putting on, has said that one good reason to do field tests is we want to know as soon as possible if this doesn't work. So we want to get it off the table, if indeed it is going to get off the table, and that sounds pretty sensible too. Another argument that's offered by Keith and Josh Horton and other people in the Harvard group is that the way you don't want to decide to do geoengineering is in a rushed and hurried way when you're facing an imminent crisis. And so if you do a lot of the work now, that will save you making a rushed and ill-informed decision. And another argument, I think, which you can strongly make is there's lots of things that go on in the climate that we need to know about and that we don't know enough about yet. And clouds in particular are one of those things. Like, the more we can know about clouds, the more we will know about climate sensitivity and what sort of future we have ahead of us, regardless of climate engineering. So we need to know about clouds. We need to know about ship exhausts. One of the most staggering factoids I heard early in this discussion is I heard this guy stand up and say the International Maritime Organization has just decided to reduce the sulfur in ship fuel. So, you know, ship fuel, very dirty, very heavy kind of diesel oil. So they passed a regulation to reduce the sulfur in ship fuel. And in passing that regulation, they ensured the equivalent of 10 years of greenhouse gas warming. Because by taking away those particles, you took away the reflectivity and you warmed the planet. Now, I don't know if that was true when that guy mentioned it, but it was sort of this staggering thing that this wasn't about greenhouse gases, it was about ships and burning fuel. So it's good to know about aerosols, it's good to know about their effects on clouds. These all, I would say, are good reasons to pursue field trials and to pursue them sensibly and responsibly. But then there are also risks. And one of the risks often mentioned is the idea of buy-in through vested interests, and buy-in can lead to lock-in. So if you start off down a path, are you more likely to continue on down that path if you have a certain set of actors who are pursuing this particular goal? They're raising research dollars, they're building infrastructure, they're building institutions. Do you end up sort of heading down that path a little more forcefully than you might otherwise have done? We mentioned a little earlier the idea of a geo-clique or a climate clique. The worry here is it's in part that you have a clique that pursues a particular goal, but it's also that you need to know who this clique is going to be. Is it going to be a particular group of people? Or is it going to be a group of people that's equally divided around the globe? Is it going to include the people that are most vulnerable to climate change, or the ones that are least vulnerable? You don't want that group to be too small, and one of the worries about field testing is that that group could become too small. Along those lines, if that group is too small, the debate could get framed too narrowly. So a set of suggestions could be made about the way to solve the climate problem, and all the debate focuses on that way to solve the climate problem. That might not be the only way. There might be many other ways you could solve it. So there's a worry about a narrowing of the parameters of the debate. And then really this is sort of a summation of some of the arguments against. Is field testing going to distort that line? Is field testing going to shift that path in ways that are undesirable? So just to return to the point that I made right at the start, my sense is that we're at a big moment, and we need to sort of think our way through this big moment. If we're going to go down that one path, we need to go down it very slowly, very thoughtfully, because we're entering, as I said before, something I've called the synthetic age. If you're interested, that book's coming out in a couple of months where I say more about what I think the synthetic age is. But because that path is such a big one, such a major one, we need as much back and forth as we possibly can. And more than any of the other areas of applied ethics in which I've worked, climate engineering demands scientists, ethicists, political scientists, social scientists, anthropologists, historians. We all need to be involved in this one because it really is a big one. Thank you.
All right, thank you very much, Christopher. That was great. So some great perspectives, some complementary, some contrary. That's really interesting. It's a very full discussion. I want to go ahead and just, before we continue, want to thank all of our presenters. They did a great job. So let's give them a round of applause. So before we start the Q&A, and actually the presenters may want to, all of our panelists may want to venture up front and take a stool up here, because we'll start the Q&A in a minute. We do want to go ahead and just give you a little bit more additional information. If those of you who don't know, Cascadic Climate Action is the organization that puts these events on. And what Cascadic Climate Action does is they're really about providing information and resources so people can take action on behalf of the climate. So if you haven't taken the time to sign up for information about Cascadia Climate Action, please do before you leave. Take a look at their website, which is chock full of great information as well as a calendar. What you can learn there, you can learn about climate events. If you enjoyed this event tonight, you can learn about a lot more of our climate science on taps, as well as other events that are going on. There's the climate events calendar, which is also incredibly useful. And you can get regular updates. One of the nicest parts about the Cascadia Climate Action website is it gives you a lot of different opportunities and ways to get involved and take action. And these might be lobbying elected officials, or commenting on proposed projects, or joining with groups to plan and act. So please, I encourage you all to take a look. Before you leave, we're going to be handing out cards with information about actions that you might be able to take locally and soon on behalf of the climate.
So the question is whether or not there's a way to mitigate things like ocean acidification through some kind of climate engineering as opposed to through carbon dioxide removal. The answer to that is no. Carbon dioxide, because it dissolves in the ocean, is going to continue. If we continue to increase the concentration in the atmosphere, it will dissolve into the ocean, and ocean acidification will continue to occur. We can think about modulating both climate and precipitation by solar climate engineering, but we can't deal with the ocean acidification problem except by removing CO2. Well, I don't think it's unachievable. I think the problem right now is it's got a long time horizon. All right, so we can't. There's nothing. So I'm not quite sure what you're asking. There's no way for us to reduce ocean acidification without removing CO2 from the atmosphere, right? And that's going to take us 30 or 40 years. So we can look at trying to modulate the temperature by solar climate engineering during that time.
I think your microphones are on. All right, great question. You have any other questions?
We were thinking here purely as geoengineering as a solution to global warming as a problem. Why couldn't we use geoengineering for other things? Changing precipitation patterns, making life better for people. That is completely different to solving the CO2 problem. I wonder if people could comment on that.
Great. I guess I'll make a comment. To use it to address other problems would be to fully enter the synthetic age, because it would be to say, all right, we've figured out now how to modulate incoming solar energy, and so let's start sort of tweaking things so that the planet's a better place to live. And I would say at the moment, we haven't yet entered the synthetic age. And to do so would be a decision. It asks questions of all of us about, what we think of the planet and what the planet is for and what sort of a home it provides. And so what you're proposing, I think, is not unreasonable, but it is a step across a threshold that we all need to be talking about before we actually do it.
If you do you can do a calculation of. Everybody's heard of Moore's law, how computers are getting faster and faster and exponentially. There's a similar Moore's law you can do for the energy use of the planet, our use of electricity and fuel. If you follow that through, that also follows a Moore's law, and the Moore's law there says that in 200 to 500 years, we're going to be using all the energy from the sun. So the idea that we're not yet in a synthetic age may be true, but it's inevitable that we're going to enter a synthetic age in the sense that we're going to be using all the sun's energy. So thinking futuristically, it's hard to believe that we wouldn't use geoengineering in some form in the future. I don't even think it's a choice that we have.
Anyone want to respond?
Yeah. This doesn't seem to... Oh, it is working. Okay. Well... You stopped me with the this is inevitable kind of claim. I don't see anything at all that's inevitable about this. The sort of law for the use of energy that you're talking about, that's a model of human behavior. It's certainly subject to choice and deliberation. I don't think there's anything inevitable about it. It's true that, as Katrina was arguing earlier, we can sleepwalk into things. It might be in that sense inevitable. If we keep sleepwalking, that will happen. But there's absolutely no reason why we couldn't make the choice to move in a different direction. After all, thousands and thousands of years, humanity lived on a lot less energy than it lives on now, and still does in many, many parts of the world. Right? It's true that a certain kind of culture, which we are, privileged or not to be part of, does use a lot of energy and continues on an upward trajectory. But I don't think there's anything inevitable about that. Even if it's a good thing, I don't think it's inevitable. And then the second thing I would say about this, this idea, well, we could engineer for climate change, but we also just geoengineer to make the world a better place, right? And maybe those options are on the table, but I think it's pretty clear that they do raise distinctive questions And one way to see that quickly without a lot of argument is to think of the analogy. There are lots of technological interventions we make into human bodies right now, you know, pacemakers and the like, but we're still kind of at the thin end of the wedge there. We could go fully cyborg, right? And people talk about this as an issue, but it seems to be foolish to deny that there aren't major choices to be made and major values decisions in making the decision to go fully cyborg. And also, I would say, ethically very dangerous, very risky to assume that, you know, going fully cyborg would be to the maximum benefit of the people, if they are still people, that do that. It's dangerous to assume that. It's just dangerous to assume that going full geoengineering at the planetary scale would be all for the good as well.
Really great. Could you go ahead and ask your question over the microphone? Oh. So I gotta.
You mentioned 2 experiments happening in the U.S., and I'm just curious what other countries have been experimenting with or discussing, even if there aren't federally funded programs.
So we've had an experiment that Germany did several years ago that involved putting iron in the ocean and looking at the effects of iron fertilization. Germany's no longer doing that. We had an experiment that was tried in England that was part of a sort of a weird experiment in some sense. They were going to have a balloon about 1 kilometer off the ground, and they were going to shoot water up through a hose. It's sort of a prelude to doing the stratospheric aerosol experiment. That got canceled at the last minute because of some political issues. And so right now there's no other experiments planned than the 2 that we're talking about.
Interesting. Right. Other questions from the audience? Yeah.
Just to follow up on that, I know a big part of the Paris Accords was the fact that we had the Global South and the Global North collaborating and working together toward solutions. And I'm curious about, on the ethical standpoint or from the science standpoint, what you would say about the voice that the Global South has right now in terms of these experiments or the governance. I mean, we know it's really important that they're part of these conversations because they haven't contributed as much as developed countries. So what would you say about their current collaboration and participation in these conversations?
Can you hear me? You asked about ethics and science, but I think that's fundamentally a political question. And the short answer is, unfortunately, to my knowledge, not much. The conversation has been pretty heavily critiqued for being one that's primarily been focused in North America and Europe to date. And I think that's something that we need to start thinking about pretty seriously, about how to broaden that conversation to include some of those voices.
I just attended a conference in Germany. There were about 270 people at this conference. It's basically about the discussions on climate engineering. And there was a group of people, about 30 or 35, who are part of a program sponsored through Germany, through an NGO in Germany, to bring in these voices from the developing countries. So they were from across the spectrum. And it was pretty interesting to have them engaged in the conversation. But one of the things that that is part of the problem is they're just getting started in that conversation. And so there's a good thing about this program is trying to bring them along in that conversation and supply them with a background that we've already got.
Can I add? Just one other thing that is also planned in terms of ways of widening the conversation to include some of those voices is a couple of us here tonight are part of a group called the Academic Working Group on Climate Engineering Governance. And one of the things that group is trying to do is to put forth some recommendations broad recommendations for governance at various scales and in various contexts. And one of the plans for that document, once it's released, which should be sometime next year, is to take it on the road and to take it to, there's plans right now to take it to India and to take it to Brazil and to solicit feedback from interested stakeholders in those places. So that's just one example and a small piece of how we need to start thinking about broadening the discussion to include some of those voices.
Do you gentlemen want to add anything?
I just want to add, it's a wonderful question, and that term geoclique is the term that some of the ethicists have been using, and that's exactly the worry, that you don't want these decisions to be made by a small group of people, and you especially don't want to exclude those who are most vulnerable to climate change from those discussions. So whatever efforts can be made to broaden this conversation really should be.
Excellent. I think we had a question up here, and then we'll get to you.
Over the next 15 years, are the, I guess, R&D field testing costs, if you had what you wanted, significant enough to impact, if there was the investment in things like deployment of scale solar, things like that, which is one of the arguments against nuclear, is that it would take money away from clean energy deployment. And the opposite side of that is that, are there significant business opportunities over the next 15 years that would cause somebody like Elon Musk to jump into this with a business case?
Pretty interesting question. Let me start with the second one first. It's not clear that you want Elon Musk or similar jumping into this. One of the things that we've talked about is who owns the intellectual property for what we're doing, and it's not clear, and there's an ethical argument here about getting locked into a particular technology because you've got somebody invested in it who wants that technology to be the one going forward. So I think you really want to be careful at this stage of the game about saying, yeah, somebody's going to buy into it and become the owner of those intellectual property rights. Well, right now there's not a business case, but I can't tell you if there's going to be a business case in 15 years. It's not clear to me there's a business case for going to Mars either. But we've got people who think there are. So the first part of your question was, what is this going to cost us? So my guess for the costing of the kind of program I put up there is $50 to $100 million a year. And you can argue about where that's going to come from and whether that's a lot of money, but it's a lot less than one aircraft carrier. All right, so it's a matter of what your priorities are. And right now, climate research and geoengineering research has no priority in this country. So it's really not the question of whether we're stealing money from somewhere else. It's a question of whether we're actually going to invest in a problem that needs to find a solution. And there's plenty of money if we want to do that. We just have to take it from the appropriate places.
Great question. Yes, back there.
Hi. It seems like the process for getting regulatory approval for implementing geoengineering on a global scale would be massive in order to get enough countries' approval and get effective, ethical considerations for all the different aspects of this. And I'm wondering how much, that would take sort of political capital that could be more effectively used towards reducing carbon emissions, which is the cause of the problem instead of the symptom, which is the warming. So I'm wondering if putting such an emphasis on getting geoengineering approved internationally would actually reduce our ability to reduce carbon emissions globally.
It's a great question, and that's one that a lot of people have been asking, and I would say one of the fundamental primary rationales for why it wasn't discussed in the first place, or was not discussed for a long time, and why many organizations are still hesitant to start engaging in this space. So it's what we kind of commonly call the moral hazard argument, right? So this idea that if we turn towards geoengineering techniques, doesn't this pull attention and resources away from what we actually really need to do to solve this problem, which is reduce our greenhouse gas emissions? So first of all, to be crystal clear, I'm not advocating for geoengineering, period. And secondarily, I'm not advocating for international organizations to approve it, or that it should be thought about as a substitute to aggressive greenhouse gas mitigations. And I think probably most scientists agree with that too, right? That are working. You said that earlier today. So yeah, it's something we need to be really careful about in terms of the way we frame the way we think about frame the way we talk about and think about governance, such that it's never thought about or framed in a way as to sort of be a replacement or a substitute for what we really need to do, which is reduce emissions. But it might be, maybe, we might find ourselves in a situation where we need it for a short period of time, and maybe not. I don't know what the answer is to that question. But I do know that I'm not advocating for, none of us are advocating for any sort of international organization to be created to approve this technology or use of this technology on a global scale.
Great. Do we have other questions? Oh, I'm sorry. Did you want to?
A quick word.
Sorry, I didn't mean to cut you off, Christopher.
Sakina's right to point out this term moral hazard. If you do this, then what's the cost? What do you lose on the other side? But I just wanted to add to that. If you think about, I think this was inherent in your question. If you think about the complexity of coming to some sort of global agreement, and somebody had a picture up there of the Earth with a thermostat on it, the idea that 190 plus nations would come to an agreement as to where that thermostat should be set, clearly we're faced with a significant political kind of challenge.
That's great. So just as a reminder, if you have a question, we have the microphone in the back, or you can turn in your cards. Also, if you're thirsty, our servers are circulating around. Schwa is here, as well as Megan. So let's go ahead and move on to our next question.
Sure. For the climate engineering field test that's being contemplated, I was wondering if there are a set of well-defined metrics that have been developed for evaluating whether or not it is a successful field test or not. And in addition to that, I was wondering what you feel would be an appropriate process for review of such metrics for any future tests. Shouldn't something like this be subject to all the rigorous scientific peer review, and how large a set of peer review would you feel would be adequate for determining the relevancy of those metrics?
Boy, that's a question that deserves a long answer, and I'll try and give you the short one. We believe that the experiments which we're proposing should go through the same kind of peer review that any experiment, any field program that we propose, that atmospheric scientists, climate scientists propose to do, should go through that same kind of set of hurdles. The way in which you would design that hurdle is one that we're familiar with, but we're generally familiar with that under federally funded programs. All right, so one of the issues we have right now is the money that is being used to do these experiments is not coming from federal sources. So the kind of normal oversight that would occur through the National Science Foundation if they were funding it, or the Department of Energy if they were funding it, is not happening because that is not in place. So that leaves people like Rob and me, or the guys at Harvard, to set up our own sort of internal review process in order to assure that we have the adequate review that you're talking about. I don't think that's ideal, but it is where we're at the moment. And until we reach a threshold where we start addressing things that might fall under environmental impact statements or the equivalent, that would be the only thing that would trigger any change in that. And both the stratospheric experiment or the sort of spraying experiment we're talking about don't actually, I mean, we could write an environmental impact statement And the folks who look at the environmental impact statements would look at it and go, why are you doing this? There's not an impact here for us to review. So right now, there is the review process is basically left up to the individual investigators until such time as federal government starts funding it, and that level of oversight that normally occurs with federal programs will happen. The funding that we have and that people at Harvard have are coming from private donations from philanthropic sources.
So, Tom, just to follow up on that, you think these are internal review processes? In that case, would you advocate for an internal review that is mostly the atmospheric scientists, sort of the physical scientists, or do you think that including folks from a spectrum of disciplines would make the most sense?
Right now, that's most of this right now has not gotten developed because the experiments aren't actually, in process, at least for us. I would think about an oversight board, and we've talked about forming such an oversight board, would have scientists on it to review the scientific part of it, but would also have people from the sort of political side, from the ethics side, and also from the community side, because our experiments will be located somewhere where there's a community and you want to engage that community. And we sometimes have a little difference about exactly who that community is, but we actually agree on that view of the world.
Great. Anybody else want to comment on that, or?
I guess I'll say something short on it, and I'll start my response the same way that Tom did, which is to say that deserves a really long conversation. But at the end of the day, I think Tom's right that we do agree at some level, and I'm glad to hear you say that you're thinking about this oversight board, because I didn't know you were planning that. I think it's a great idea. But I think fundamentally the public has to be involved, and it's not about evaluating the sort of validity of his scientific findings, but it's more about identifying parts of the research that maybe are in his blind spots, right? That might have to do with ethical issues or political issues that are outside the sort of scope of what Tom's expertise is, which is broad and vast, but not all-inclusive. So I would advocate that it needs to be much broader than just the scientific community, even just the expert community. It needs to be much broader than just the expert community to include people who are potentially impacted by decisions that may follow from whatever path we decide to take on this topic.
Great. You have a question?
Hi. I actually have two questions. My first question is more from a lay standpoint because I'm not in this field, so I apologize if it's dumb. But are there any fears that more widespread testing would affect storm severity? That's my first question. And then my second question is, it was mentioned earlier that this needs to be interdisciplinary conversation. Obviously, this is an interdisciplinary conversation because of you guys, but what is maybe the most difficult sector to engage in this, and how can other disciplines start that conversation? Yeah.
Cool. I'm going to take the first one because that's easy, and then I'll let them have the second one. As long as we're talking about doing these sort of initial process tests, then there's really no thought that we would affect storm severity or anything else. There's sort of that next generation I showed on that slide, that kind of arc. When you start getting to saying, oh, I'm affecting the reflectivity of the planet, or I'm affecting temperature or precipitation in some part of the globe, then you want to start asking for sure the question you're talking about, how do we know what we're affecting, and what do we think the sort of limits of that effect are? I would point out, for the kinds of experiments we're talking about, those ship tracks that I showed you are a bigger impact than what we're talking about. So it's going on every day already at that level.
Thank you.
Okay, you guys.
One comment I would just make about which sectors have been hard to pull in. There's really been an explosive growth in this literature, and particularly in my area, which is environmental ethics, which is kind of a small area. when people first started talking about this, which was around about 2010, the discussion really started to take off. A bunch of us just burst onto the scene and just said, this is outrageous and this is horrendous. And even David Keith, who is an advocate of the research, he said, all other things being equal, this is a horrible idea. So there has, in fact, been a pretty rapid entry into this discussion from a lot of different areas of the academic world. The discussion, it's interesting to watch. The discussion is maturing a little bit now. The sort of initial reactions, the initial shock has passed a little bit, and people are sort of settling down a little bit. And I think the discussion is continuing to get broader. So I wouldn't, from the academic side of things, I wouldn't worry that no one's interested in talking about this, because it's an area that people have found themselves very interested in talking about.
In fact, following up on that, I would say one area where there needs to be much more engagement is from the public at large, from communities, because there's a risk that some of this stuff will, pretty quickly outstrip any public readiness to talk about it, and any possible appetite for it in ways that could backfire politically, and including on the researchers involved. So I think there needs to be greater engagements in that way. And I think some of the initial, negative reactions still need to be taken pretty seriously. I mean, two that have really interested me. I mean, one thing I've emphasized is that there's no guarantee that geoengineering technologies will be used well in the best interests of all people and non-human nature and so on. One particular risk that I've tried to highlight is it might be very tempting for the current generation, broadly conceived, to pick a geoengineering technology that holds off the worst impacts of climate change for, 50, 100 years, as long as, most of us will be around, and not really worry about what happens after that, including if what happens after that is it makes things much worse for future people. I don't see any reason to believe that won't be what's selected, and I think we'd want to have strong reason to believe that won't be selected before we proceed in a dramatic way. And the other thing that's really interested me is that the ways in which the debate sometimes gets phrased in terms of a moral imperative. We must do this, right? We must engage in this kind of research. Right? We just have to do this. Where the background is, because there's so much at stake, we risk climate catastrophe and so on. But what I want to caution about that is there's lots of other stuff we could do to diminish the risk of climate catastrophe. There's been lots of stuff we could have been doing for 25 years or more, and we haven't actually shown much interest in doing that, and that's a big reason why we're currently thinking about climate engineering. So as I put it in some places, we face the paradoxical question, what morally should we do given that we're not doing, and we haven't done in the past and we continue not to do what we morally ought to do. So I think both initial reactions are still very important here.
Interesting. You have a question over here? Oh, that's really interesting. I can imagine a t-shirt with, that's all right, the geoengineers have it.
Please no. Let's not do that.
Trademarked.
So really the best answer I can give to that question, and it's a really good question, is I really hope not. I don't think anybody knows the answer to that question, and I think as a someone who sometimes is framed as a political scientist, I will say that this is why the way we talk about things, this is why framing really matters, and the way that we design institutions and the way we design policies to ensure and provide safeguards to ensure that type of framing never becomes the way we move forward is critically important. So yes, is it something to be concerned about? Absolutely. Is it an inevitability? I don't think so.
I was hoping to use that idea for a T-shirt to raise money for Rob and me to do our work, but
crowdfund. Do you have something to add?
Just one more thing to that question. It falls roughly into that moral hazard concern that kind of came up earlier. Part of this discussion has included the idea that there might be a reverse moral hazard. In other words, once you start talking about geoengineering, it's not that people say, don't worry, the geoengineers have got it covered. They say, good God, geoengineering? Let's do something about emissions. So the argument's been made both ways, that geoengineering discussion could be bad for emissions reduction, and it could be good for emissions reduction. And it's sort of an empirical question that nobody yet knows the answer to as to which one it is.
Great. So I'm just realizing what time it is. It's 8:30, and I want to be respectful of our panelists and of all of you. So at this point, I'd just like to close the Q&A, and I just want to thank our panelists again. Let's give them applause.